This is the second video which you're being shown how to use point plotting as a method of graphing linear functions.
In the first video where I went through this, I demonstrated some instances of how you would graph equations with two variables just by using point plotting. In this video, we're going to work through some additional ones where we start seeing a little bit more difficulty as we move along with them. So let's have a look at the first example. So make sure that you pause this for a moment, calculate some x and y values, see if you agree with any of the ones that I calculate after we come back. But do that and then try to see if you can make your own graph and see if your graphs agree. So hopefully that you now pause this a bit. Again, this is still considered to be a somewhat easier circumstance because both coefficients over here are factors of the right-hand side. When that stops being the case, it gets a little bit more complicated, and you're going to start seeing whole number x values producing many more fractions, and finding ordered pairs that are both integers or whole numbers of any kind becomes fewer and far between. So again, just to kind of show it, I did a little differently. I started a table here, and I picked some x values and some y values, to see, so if I could calculate them. So, like, for instance, for the -8, I plugged -8 into the equation for x, worked it out to get that y equaled 0. For the next one, I went to the equation and replaced the y with a 3. So I got 3x minus 4 times 3 equals -24, which is 3x minus 12 equals a -24. I would add 12 to both sides to get 3x equals -12, which means x would be -4. So again, it doesn't matter which, if you're choosing the x and finding the y, or choosing the y and finding the x, it still works regardless. For y being 6, same thing. I just did 3x minus 4 times 6. And I got the 3x minus 24 equals a -24. I added 24 to both sides to get the 3x equals 0. And then I added up divided by 3 to get that x equals 0. So 0, 6 is the ordered pair. And you see each time as I do this, I am plotting the other point. And then lastly, for x being 4, I'm just going to go back to the equation again, replace x with 4. You have to make sure that you're replacing the right variable. If I'm choosing an x value, I'm putting the number in for x, and I'm calculating the y. If I'm choosing the y value, I'm putting that value in for y and calculating the x. Just to be clear about what I'm doing. So 12 minus 4y equals -24. Subtracting 12 from both sides, I get -4y equals -36. Dividing both sides by -4, I get y equals 9. So 4, 9 is the last point we have on there. And you can see that I have these 4 points. They are forming a linear pattern here. And so I could draw a straight line through all 4 of those. And there's many other points that would work as well. But that is the line being represented here. In the previous video, we did talk about a special circumstance where we had x equaling a number. Here we have y equaling a number. And some of the logic behind this is very similar to when we have x equaling a number. In this case here, we have y equaling 8, and that means that y is going to equal 8 regardless of what x is. X does not matter as far as what calculating y is. No matter what x is, y is going to be 8. So I can reflect that in the table by saying, okay, I'm just picking some random x values, but they could be any numbers in this column over here at all. No matter what the x value is, y is just going to stay 8. And you can see I plotted these particular points here. And you can see that, if I have just y coordinates that are 8 and x could be anything, they're forming a pattern, a linear pattern along this horizontal line. So, when I have y equaling a number, I am getting a horizontal line for that instance. So x equals a number is a vertical line, y equals a number is a horizontal line. One of the things that we start seeing here, and the reason why it becomes important for us to come up with other methods to graph things, is because just picking random points does not always work nicely. Case in point here, I have -x plus 2y equaling 7. So I want to start a table here, and maybe I'll get lucky with some of these, maybe I won't. So if I say let x be -2, 0, 2, and 4. Well, when x equals -2, and I put these values in, These are the values of y I get. Now, these aren't too bad because if I put these numbers in, I can kind of guess where 2.5 is, but I am still ultimately guessing. And if I start getting other decimals or other fractions, then it becomes more of a guessing game, especially if the graph is not scaled that way. This graph is scaled to go by ones, not by 0.5. So I'm guessing where the 0.5 would be to some degree when I do these. So, so it gets harder to start getting values that, where if I put in a whole number x, I get back a whole number y. I mean, there are some, if I let x be negative 1, 1, or 3, I do get whole number values for my y's. And you see I'm going to plot them here. Here's negative 1, 3. Here's 1, 4. And here's 3, 5. I can see they form a linear pattern. And if I plot the other ones, again, taking guesses, that's where they would end up. I can see they all still line up in a linear pattern. So the line would be here. But as you can see with this one instance, it starts getting more of a guessing game about where I plot them, especially if my graph is not set up to handle that. And that happens a lot when I have circumstances where, I have x's, I have a coefficient. This one had a coefficient here where this is not a whole number factor, the 2y here, the 2, is not a whole number factor of 7. This one's still not too bad because negative 3 and negative 5 are both factors of 15. So it's not extremely hard to come up with some values. And for some reason, the negative 27/5 for y didn't show up on this. Picking x to be 4, would give me, as you see down at the bottom there, and for some reason it didn't make its way up to the table. Well, wait, if I do it, I think it just got out of order here. Negative 27 over 5 equals negative 5.4. Thing is, again, that's a value, that I put in a whole number of x, whole number value of x. And this could have happened with some of the other problems that I've shown as well. I mean, there were values of x or y I could plug in to get a value of, the other one that would be a decimal or a fraction. And, then it becomes, again, a guessing game about where I put that because, these two, these two here come out exactly. If I could get it to work right. So yeah, these two come out rather nicely. However, this one here, I'm guessing a bit. So going back one step before I show the line, negative 5, 0, I'm pretty confident with that. 0, negative 3, I'm pretty confident with that. Negative 5.4, or 4 comma negative 5.4, not so much because, the 4 I'm confident with. I know it's on this grid here, but, negative 5.4 would be a little less than halfway in between, although it looks like it's kind of halfway in between. Still looks like it lines up pretty well. But again, accuracy is what we're looking for, but we're also looking for accuracy in a manner that could be done rather quickly as well. And you can see just plotting points makes it a little bit more difficult. So we do come up with other methods for doing this, which we're going to be learning over the next couple of modules. So
that's the end of this video. As always, if you have any further questions, please make sure to get in touch with me. Until next time, have a good day.